This is our third and final video labeled Evaluating Logarithms. I just want to make 2 points on this video. One is, sometimes after you evaluate a log, there's math to do. Sometimes just evaluating the log isn't the end in itself. This is especially true if you see formulas that contain logs that are used in the science or medical fields. So looking at this right here, this is going to be 2 times this logarithm plus 5 times this logarithm. Let's go ahead and evaluate these logarithms. And the log to base 3 of 9, what power do I raise 3 to land right on 9? That's really just a 2. So we've got this initial 2 times 2 plus 5 times, and now I have to go find this exponent. 4 to what power lands right on 64? Well, 4 times 4 times 4 is 64. So that looks like we're multiplying 3 of those together. So 4 to the third power is 64. Now we've just got some arithmetic to do. So 2 times 2 is 4, plus 5 times 3 is 15, and our final answer is 19. So I want you to understand that sometimes evaluating the log isn't the final answer that you're giving. Sometimes they ask you to do something further with it. Okay, so the last point of this video is, and this is a very, very important idea. How do we evaluate a log that looks like this? Log to base 8 of 8 to the 17. That might look a little bit scary, but it actually isn't. When you do the clarification by writing it out the other way, 8 to what power lands right on 8 to the 17th. So looking at this equation, what do you think could go in this box that would make this be equal? Well, 8 to the 17th is what 8 to the 17th is. If I raise 8 to the 17th, I get this. So let me look at a couple more that are along the same lines. What if I had the log to base 93 of 93 to the 5th? What power would I raise this to in order to get this thing? 93 to what power equals 93 to the 5th? Well, the only way these could both be true is if this was 5. So the answer is 5. So it's kind of like the answer is embedded right in the question. It's kind of like what you used to hear as a kid, who's buried in Grant's tomb? Well, probably Grant. So basically the only way this works is if this and this match. The base of the logarithm and the base of this argument, this exponential thing that's written right where the argument is. So let's see if we can summarize that. The log to any base of that same base to some power, I'll call it p, is equal to p. What power do I raise this to if I want to get this? I raise it to that power if I want it to look like this. If you ever hear me referring to the little red car theorem, that was a pet name I gave this kind of idea a long time ago after a friend of mine who taught me pretty much everything I know called it the same thing. So basically, my little red car theorem says, what color do you paint your car if you want it to look red? Red. What power do I raise b to if I want to get b to the P power? P. The answer is right within the problem. Now, that only works if the two bases match. So you might say, how would you handle something like this? The log to base 2 of, oh, let's say 8 to the 40th. Now we have the problem of this not matching that. So I could not use that idea that we just developed to answer this right here. But what if I could write 8 as 2 to a power? 2 to the third is really just an 8. So what if I put this in place of that? And what if I used a property of exponents? I said when you have something to a power, to a further power, you can multiply the exponents. So 3 times 40 is 120. This problem right here is equivalent to what we started with, because all we did is replace an 8 with a 2 to some power. So long as there is an easy enough way to rewrite this using that base right there to some power, you will be able to maneuver it until these do match. Now I can say, what power do I raise 2 to get 2 to the 120? Well, 120. 2 to this power gives me this. I hope this has been enlightening.